In software development and software engineering, there are many questions, many basic questions that you need to ask about the architecture, and here we are going to try and answer some of them for my own view, experience, and some material that I was reading recently. So some of these questions are like, which programming languages do you use? Should you use Java, Python, Clojure? Okay, C, C++, PHP. Which databases should you use? NoSQL, relational database. When do you write unit test, integration test, end-to-end test? And so forth. Okay, should you use Scrum or Kanban or in Agile? What are your processes? How do you deal with the deadline? So first, as for the languages, Java is a bulletproof language for large teams or a large set of teams where you need to cooperate. It's very difficult to do this with other languages. It's possible. There are people that would tell you that there is no problem with it. They are managing to do this, but I think that it's rather hard because Java is really bulletproof. It has been here for more than 20 years. It's statically typed, the IDE supported fluently, super huge projects and super huge companies with thousands and tens of thousands of developers and maybe thousands of teams are using Java successfully. It's great for cooperation. Okay, this is a great language to standardize your software development. As for C#, use it if you're just simply living in, use it for the same reasons that you would use Java, only if you are living in a Microsoft environment. Python and Ruby are quite similar. They are dynamically typed. First, if you're using AI and models, then there are many open source projects in Python. So in many cases, if you're doing like models and AI, you would use Python in order to utilize Jupyter notebooks, in order to utilize modeling. It has some issues with scalability that in Java and Scala and JVM languages was solved with Spark. And though you have PySpark is not enough in order to interact with the Spark because you still need to convert these data structures at least underground, and also Spark assumes that your process is simplified. They are trying to create all the algorithms that are already existing in Python, and for this reason there are new projects in Python that try to make it more scalable and to run like Python. As for JavaScript, I have a personal answer. You won't like it. Don't use JavaScript. And that is because that usually what you end up with is like a jungle of code. Even though if you try to make it neat, I know the most of the web is written in JavaScript, but it's a very problematic language because of the tooling around it. It's dynamic. You add features. The nature of frontend is that you add and change features and it needs maintenance. So if you're a solo developer or a solo team, it may fit you perfectly. But the one who would come and would try to refactor something or try to manipulate it, it would be very difficult for him to learn. I'm sure there are a lot of horror stories about it. What you could do, but there is a solution. I mean, you don't have to use JavaScript. You can use TypeScript. TypeScript is a superset of JavaScript. You get all the benefits. You can write to the browser. You can just transpile it from TypeScript into JavaScript, and you get also all the benefits of type safety. Okay, another suggestion that I would suggest is that although today the web is very dynamic and stuff like this, you could use the Phoenix project in order to move most of the front end into the backend, and this would greatly ease all the work and all the code that you need to maintain. Okay, because if you're a solo developer writing JavaScript, you can be very fast in it. Yes. If you're a team that's writing a throwaway project, then yes. If you're writing a prototype, then yes. But if you want something maintainable, multiple teams can use, new people can come and maintain, you could refactor, you could clean up the code, then it does not answer this. Okay, Now, about C and C++, you don't really choose these languages. If you really need them, you would know. Okay, you would know you need to really need them. Although today there are new languages that would answer many of the places where you would think that you need C, like Rust and stuff like this, because they don't have a garbage collection. They support object cleanup without garbage collection in the compiler. And you could just use Rust for something like fast video transformation and mathematical operation. As for PHP or its a current language named Hack, which is a great name for PHP, it's like, again, if you're a solo developer writing a server, you want to quickly iterate through it, or you consider yourself a non-developer. Many non-developers are using PHP. And today there is the great framework Laravel, which is very similar to Rails, only it's on PHP, and you can create, if you're good at UI, you would want to use PHP for personal projects or for standalone projects. One team handles them and no maintenance. This is the language for it. About microservices, when should you use it? I would personally prefer something in between microservices and monolith. There is a term for it. It's called Modular Monolith, where you take some benefits from both. It's not really eating the cake and leaving the cake full, but it's taking some properties from microservices and also from monolith. You end up with a single monorepo. And this will help multiple teams handle this monorepo. They will have visibility on all the code, because one of the drawbacks of using microservices is that you have less visibility, okay, into what the other services do. So on one hand, this is good, but on the other hand, it's not so good, because when you do need to look at what the other code is doing, it's very difficult. Okay, so it's very good when you want a company separation. If you want to treat multiple teams like different companies, then microservices are good. But remember, if you're in a state of mind of microservices, then you're in a state of mind of multiple companies. And imagine what it means for one company to call the API of another company. You would need permissions. Okay? You don't have access to logs. You would need good documentation. You would need all this. You would need how do you trace the requests. Okay, so therefore I prefer the modular monolith in this case. As for a database, when you need to choose a database, I think that the first choice should be an SQL. Could be MySQL, could be Postgres, or even better, something managed so that you won't need to manage the server of the database by yourself. So you choose a managed service. They will do good for you in 99% of the time, even when you think you need a NoSQL. In many cases, in 9 of 10 cases where you think you need NoSQL, you actually need an SQL. In the 1 of 10 cases where you do need a NoSQL, this is when your access patterns into the data are well known. What does it mean? That your access patterns into the data are well known. You know exactly which data you're going to get. You don't need a complex query or semi-complex query in order to get the data. Then in most cases, standard SQL would be good enough. As for testing, you write a unit test when you have a complex algorithm in a function or a complex thing. Okay, you don't write unit test in order to test things, as weird as it may sound. Because if you try to test your server with unit test, you will end up with many small tests and you won't really know if your server works correctly. So you would say, okay, but I'll add system tests. So I would say, don't add the system test. You could add a few system tests, not too many, because they're very hard to manage. You need the server to be up. You need to configure the database. You need to clean up. You need to prepare the data. The system tests are very complex. what you actually want to have is a component test, and end-to-end test. The test flows inside your servers while your server is down. When do you need to write a unit test? You do need to write a unit test if you want to verify like the architecture or the function parameters. You want to see that it makes sense. Okay, you could write a unit test, not too many because there are additional code to maintain. Or when you have a very complex function, a very complex computation and algorithm. In these cases, you do need a unit test. Estimating how much time it's going to take to do something. So this is a very difficult topic, but I would say this. It's really dependent on the amount of unknowns that you have on the estimation. If the task that you're going to do is a task that you already did and you know exactly how to do it, then you could give an estimate. If you didn't do this task before, or similar one, very similar one, and you have some unknowns, then it's going to be very difficult to estimate it. Therefore, what I would say is that you need to think of the task as a whole. Imagine how much time did it take you in the past, taking into account especially the unknowns. So what you should refer to in the past when you try to come up with the estimation is not what the task is about, is more like how many unknowns do you have in the task. Is it a new project that you need to work on? Okay, if it's a new code base, try to figure out in a different situation how much time did it take in this unknown constraint of a new code base. Okay? And then you could create some kind of a table. Okay, unknown code base, weeks. Okay, the table that you create for yourself is a table that maps between unknown into times estimations. And then when you get a task, you look at the table of where the key is the unknowns, and for each unknown you have the time that it takes to do this unknown. Having said all this, whenever you have unknowns, estimating is very difficult. I also don't think that if you try to sniff around the task before on the unknowns, it's going to give some value, additional value to the estimation, because the task itself is the unknowns. Okay, so I personally think that the only tasks that can be estimated with precisions are tasks that are having very, very little unknowns, because the main thing which is difficult to estimate is the unknowns. And the problem with unknowns is that they are unknowns. So you can't really estimate those, okay? You can only compare these unknowns to some unknowns in the past and try to come up with something. The way to mitigate it, the way to mitigate the unknowns is to just start with the unknowns, okay? Just start with the task, okay? Instead of trying to estimate, just start and move along with it. Sorry, I don't have a solution for this, but this is my rule of thumb, unfortunately. The last thing that I want to tell you is that Kanban is preferable to like sprint planning and all this stuff. You should push to work with Kanban, working task by task, trying to move things forward and monitor the progress. You can work with Scrum, with sprint planning and everything, but it works better, frankly, for tasks which do not have unknowns, okay? So in these cases, you can really say, this task will take me 3.5 days, because you know you don't have any unknowns. You know exactly what are the places in code. You can imagine I'm going to go to this function, add this piece of code, I'm going to go to these functions. This is usually happening in the UI. You are told to change something in the UI, in the code base that you already know, and you know exactly how you're going to do this. You know exactly what you're going to change. You know exactly how much time. Scrum and sprint planning are good for this. But if your task is to move in the backend from one framework to another, like let's upgrade from Maven to Gradle, okay? Okay, I estimate it as 2 weeks, 1 month, 2 months. It's impossible. Sorry, but you can only take the unknowns from previous projects that you had where you needed to change some basic framework. And I can assure you that depending on the number of projects that you have, so if you need to move from Maven to Gradle in a single project with very small code, you will need to change also your continuous integration and your builds if you have some, and you would have some issues. And okay, so it can take you some small time. But if you have multiple projects and multiple teams working on this, then it becomes exponentially difficult to work around this. And while you could say, okay, so I'll gradually roll it out. I'll start with one project, move to another. I think that for such infrastructure changes, it should be an infrastructure change. Therefore, Kanban would be much more suitable for this kind of task, because in Kanban, what we do, you'll deal with it piece by piece, and you would move forward with it. Scrum and sprint planning has its problems. It's very good. It's very good for when you do have predictability. So I'm sorry that I'm ending with such pessimism, but I'm sure that if you look at your historical estimations, you will see these pictures. There are very few projects which were estimated correctly. And the main reason is the unknowns. It's a very difficult issue to handle these unknowns. So you just need to have some kind of general table which maps certain unknowns into certain time estimation. So hope you enjoy this session, and I will see you next time.